Hello, welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services based in Europe, and I'm going to be your host for this session. This is a Masterclass series webinar presented in partnership with Intel, and today we're focusing on advanced security best practices on AWS. You may be aware that we have another webinar series called Journey Through the Cloud, where we focus on a solutions-orientated look at how you can apply a variety of different AWS services to a specific use case or challenge that you might be facing. In the Masterclass series of webinars, we dive deep into one specific AWS service and take a good focused look on how you can make use of that service and get the most out of it. Having said that, today's session is not a typical masterclass because we're going to be covering several different AWS services that have relevance in the area of security control on the AWS platform. And I just want to say that we're going to be pressed for time today to cover all of the potential topics that are relevant to this area. So if you have questions that you might want to ask that are broad-based relating to security best practices on AWS, please submit those via the Q&A panel that you can see in the webinar interface, and a member of our solutions architecture team will get back to you over the course of the next few days with answers to your questions. The other things that you should be able to see in the webinar interface, firstly, you can find the materials from today's session available for download in the Files panel. So you can grab a PDF of the slides, and in common with all Masterclass series webinars, you'll find that a useful thing to do because many of the slides have links on them which will take you to further reading on some of the topics that we're going to cover in more detail today. At the end of the session, we will switch the webinar into Q&A mode. And when we do this, you'll be given the opportunity to rate today's session. So please give us a rating between 5 and 1, with 5 being the best, and let us have your feedback on today's session. We do use this feedback to help us improve our webinar program for future audiences. And if you want to leave us any qualitative feedback, you can do that once again using the Q&A panel. I'm happy to take feedback via that method as well as take questions. You can see my Twitter on the screen there. I'm also going to show you at the end of today's session a couple more social media accounts that you can use to stay up to date with AWS here in the UK and Ireland and also globally. Please follow us on social media and you'll be able to stay up to date with our education program and other AWS related news. Okay. Let's get on with the masterclass. And as I said earlier, this is a technical deep dive that is going to go beyond the basics in the specific topic area that we're covering. Intended to educate you on how to get the best from AWS services, show you how things work. And in the case of this session today, quite a few demos to show you how to get things done using some of the features that we're going to be talking about later in today's session. And the topic for today is advanced security best practices. If you joined our session a couple of weeks ago, Journey Through the Cloud Security Best Practices on AWS, you'll know that security is job zero for us. We really regard that as the foundation upon which all AWS services are built. And as a result of that mindset, I think we've been able to create a platform that satisfies the most security sensitive organizations, providing very good features for visibility, auditability and controllability, and allowing you to combine these with one of the main reasons that you might use the cloud, which is agility, of course. We'll talk about how you can achieve that using some technical features later on in today's session. And operations on AWS generally, but specifically in the area of security, we feel that you can significantly lower the operational overhead associated with traditional, maybe private owned IT that you operate. If you deliver services using cloud computing, using the AWS cloud instead, hopefully illustrate that to you during the course of this session today. So, increasing your security posture in the cloud. I just want to quickly recap this from the last session that we've done on this topic. So I do think it's important, firstly, to say that AWS has a very familiar security approach. If you check out our security center at awsamazon.com/security, you can find out a lot more information about that. And if you're a customer that has a non-disclosure agreement in place with AWS, we can also share additional information about how our security delivery works in terms of people and process, systems, network, and physical security, which might help you comply with compliance or audit requirements that are placed upon you or your organization. Also, we have a very large security team here at AWS, and as I said a second ago, we work to provide services, to create services that provide you with visibility into usage and resources, which can lead to you being able to develop a really strong security posture on the AWS cloud, something that's arguably going to be better than the security posture that you can achieve with traditionally operated private IT or on-premises IT. We have a broad range of accreditations and certifications. So these are third-party organizations and standards accreditors that have taken a look at the way in which AWS does security and have certified that approach, the processes that we use, the controls that we use, are consistent with a wide variety of industry standards. If you want to learn more about that, aws.amazon.com/compliance is the place to go, and we can share, once again, much more detail about these compliance reports and the controls that we implement if you have a non-disclosure agreement in place with Amazon Web Services. One other cool feature of actually the cloud generally, but it applies very specifically to security, is the idea of a community network effect. So very lucky at AWS, we have over 1 million customers that have used the AWS cloud in the last 30 days. And amongst those 1 million customers, there are some very demanding organizations like GE, NASA, Shell, Bristol-Myers Squibb and Pinterest, to name just a few customers that are using AWS extensively. We have a broad partner ecosystem, and combining the demands from these very demanding customers together with the AWS mindset of creating services directly in response to customer demand, we're able to create new and innovative security services that come directly from customers saying things to us like, AWS, it would be good if you could provide us with a better mechanism for managing encryption keys, for example. We build these services and everybody benefits from that. So when we introduce a new service in response to a very demanding customer, actually that benefits every customer that's using the platform. We'll talk more about encryption later because it's a really good example of this. But the community network effect in general that AWS takes advantages of in order to create services that have a high degree of relevance to customers and help customers achieve their objectives applies in a very specific and interesting way to security services. And I just want you to bear that in mind as we go through the webinar. And if you think that we're missing anything today, if there's anything that you feel we're not doing that we should be doing that might help you with security management or with maintaining the right kind of security posture for your organization, I'd ask that you let us know about that, maybe via feedback in this session or via your AWS account manager or solutions architect that might work with you. And let us know where we can do better. Let us know about the features that you would like to see in the platform, whether those are security features or other features, and we'll build services in response to customer demand. So let us know what you need from us. Okay, the agenda for today's session. We're going to recap in a second the shared security responsibility model that AWS provides. Then we're going to dive into some best practices for identity and access management with IAM. We'll then talk about defining virtual networks with Amazon VPC and networking security for EC2 instances within VPCs. Then talk quickly about container and abstracted services, and we'll close by talking about encryption and key management in AWS. There are actually quite a few security topics that we're not going to have time to cover today, so do submit your questions using that Q&A panel, and we'll get back to get back to you on those with additional information if you've got topic areas that you don't feel that we've covered adequately during this session. So, sharing the security responsibility model. This is a key aspect of operating services on the AWS cloud that you as a customer need to understand very well. And what this means is that you let AWS do the heavy lifting of operating the physical operations, the physical security, the physical infrastructure, operating the network infrastructure and virtualization infrastructure, and of course managing the life cycle of the hardware that provides our services. And you're able then to focus on what's valuable, what's most important to your business or organization. But there are responsibilities that are placed upon you through this model. We have a very clear service DMARC that we operate up to, and we provide you with a set of tools that you can use in order to develop and maintain a security posture using the services that we provide. But it's very important that you understand how those tools work and also what your responsibilities are in, for example, installing and configuring operating systems, or creating and maintaining a security policy using features like security groups or access control lists, how you might manage users' credentials in your organization using an AWS service called IAM, Identity and Access Management. So we provide technologies that you can implement to protect your data in transit and at rest. But how you use those services is up to you. How you configure the platform is up to you. And it's very important that you understand the different models that I'm going to talk about in a second, so that you can be clear where your responsibilities start and our responsibilities end. Now, the first model is for infrastructure services. These are services such as Amazon EC2, Amazon EBS, and Amazon VPC that run on top of the AWS global infrastructure. These services vary in terms of availability and the durability objectives that they provide, but they always operate in the specific region where they have been launched. So you can build systems that meet both your availability objectives by taking advantage of things like AWS availability zones, and also meet your needs in terms of data location or data sovereignty by placing your data and services into specific AWS regions around the world. Building on our secure global infrastructure, you then install and configure operating systems and platforms in the AWS cloud, just as you would on your own premises or in your own data center facilities, whether those are operated by yourself or by a co-location provider. You then install applications on your platform, and ultimately your data resides in and is managed by your own applications. Now, for certain compliance requirements, you might require an additional layer of protection between services from AWS and your operating systems and platforms, where, as I said a second ago, your applications and data reside. And you can impose additional controls here, things like encryption of data at rest or protection of data in transit, or even introduce an layer of opacity between services from AWS and your platform. And this layer can include encryption, can include data integrity authentication, software and data signing, secure timestamping, and other features. So you're able to build that on top of the AWS infrastructure services if you have a requirement to do so. Second service model is for container services. And the shared responsibility model also applies here. This is for services such as Amazon RDS and EMR. And in these services, AWS doesn't just manage the underlying infrastructure and foundation services. We also manage all layers up through the container. For example, with RDS for Oracle, we would manage all layers of the container up to and including the Oracle database platform, providing services such as data backup and recovery. But it's your responsibility to configure and use those tools in order to meet your businesses or your organization's continuity and DR policy requirements. For AWS container services, you're responsible for data and for firewall rules, security groups for access to the container service in the case of RDS, or in the case of EMR, managing those firewall rules through Amazon EC2 security groups for your EMR instances. And you're responsible, of course, for ensuring that those technical features are configured in a way which enables you to meet your security policy objectives. And then the last service model is for abstracted services. This is services like Amazon S3 or Dynamode DB, where we're providing API endpoints that are tightly integrated with our Identity and Access Management service, IAM, which we're going to come to in much more detail in just a moment. In these abstracted services, you're responsible for managing your data, including classifying your data assets, and for using IAM tools to apply ACL type permissions to individual resources, either at the platform level or to apply permissions based on user identity. And it's your responsibility to manage those users at the IAM user group level. For some services, such as Amazon S3, you can also use platform-provided encryption of data at rest or platform-provided HTTPS encapsulation for your payloads to encrypt your data in transit to and from the service. And we're going to talk a little bit more about encryption at AWS at the very end of this session, as we mentioned a few minutes ago when we were talking about the agenda. Having said that, the next agenda item is best practices for identity and access management. So let's take a look at that now. And there are 10 or so different topic areas that we're going to cover here. The first is users, and it's very important with IAM to create individual users that have unique credentials, and then they inherit the ability to individually rotate those credentials and also manage permissions individually for each user. And getting started with this is very simple. You just need to identify which IAM users you want to create in order to meet those separation objectives of unique credentials, rotation and permissions. And then you're going to use the console, the CLI or the API to create users, assign credentials and assign permissions to them. And it's that simple. Once you've done that, individual users will be able to log into the CLI using their unique identities, their unique credentials, and also be able to access APIs if you provide them with an access and secret key, a pair of AWS credentials, with the permissions that have been assigned to them. And moving on to talk about permissions in a little bit more detail, the key principle here, of course, is to work under a principle of least privilege. And by granting least privilege, you can have a couple of effects, really. The first is you lessen the chance of individuals making mistakes by overrunning the scope that's been provided to them. They're not able to do that if you provide them a least privileged set of credentials, of course. It's easier to relax credentials at a later stage than it is to tighten up, and you're unlikely to break pre-existing functionality, something that a user may have developed themselves, if you relax credentials in comparison to the likelihood of that happening if you remove or tighten up credentials once they've been issued. You're also able to effect more granular control over API and resources if you work under this principle. And getting started here is also simple, identifying what permissions are required, creating those passwords or access keys for individual users that have those permissions, avoiding wildcard, bearing in mind the fact that there is a default deny policy with IAM. You need to explicitly allow access to APIs and allow access to resources. And you can make use of policy templates and a new feature that we provide called Manage Policies, which you can attach to users or groups to simplify the process of allocating least privileged credentials to users. It's important to note that permissions do not apply to the root user in your AWS account. The root credentials are exceedingly powerful and should be treated with care, so bear that in mind. There's no mechanism for reducing permissions on the root user account. It always has all permissions for all APIs, and therefore its use should be avoided whenever possible. Groups. This is a mechanism to simplify the management of permissions. Obviously, it's much easier to assign the same permissions to multiple users by placing them in a group than it is to individually manage that. And it's simpler to manage the life cycle of a permission set if it's assigned to a group as well. Reassigning permissions, for example, based in a change in responsibilities is as simple as moving a user between groups. Or maybe you want to change the function of a group of users. Well, you can just change the permission policy that's assigned to a specific group if you want to achieve that. So it's also simple to update permissions for multiple users. To get started with this, mapping permissions to a specific business function is the first step, then assigning users to that function. Then you're simply managing groups in the group section of the IAM console. You can further restrict privileged access with conditions. And this can give you additional granularity when defining permissions, and it can be enabled for any AWS Service API, and it minimizes the chance of accidentally performing privileged actions. And how to get started? Well, use these conditions where it's applicable. And there's two different types: common ones that apply to all AWS services, and those that are service specific. And it's probably worth illustrating the use of conditions with a few examples, and you can see 4 different examples on this slide. The first is restricting instance termination, so that's access to the terminate instance API method. It's restricted to users that are authenticated with an MFA device. You can see top left here on this slide. Top right enables a user to manage access keys for all IAM users only if the user is connecting over SSL. That would force secure transport. Source IP restrictions, you can see bottom left. Once again, we're working on the terminate instance method of the EC2 API here, and we're restricting that to a particular, in this case, a /24 network and it's a private network in this case with RFC 1918 addressing. So this would be either somewhere inside a VPC or somebody accessing a VPC over a private connection via a VPN gateway or direct connect. And then bottom right, restricting to a specific tag. So we're allowing a user to terminate EC2 instances only if the instance is tagged with environment equals dev. It's a very common use case where you want to assign particular users access to work with resources in specific environments. You can tag the resources in those environments and use tag restrictions with conditions to limit what that user is capable of doing. Auditing. So this is enabling AWS Cloud Trail to get logs of API calls. AWS Cloud Trail is an AWS service for logging and recording API calls and depositing those logs into an S3 bucket that you specify. You can then use a variety of visualization tools to visualize Cloud Trail logs or write your own analytics processes if you wish to do that. And by enabling AWS Cloud Trail to get logs of API calls, you provide visibility into your users' activity. And this enables post-event auditing, maybe required for compliance with regulatory standards that you need to comply with, or you may want to use it for things like incident remediation. It's very, very simple. If you visit awsamazon.com/cloudtrail, you find a product detail page, and there's details there on the services that are integrated and also details of the very simple setup process. You create an S3 bucket, enable Cloud Trail, and then point an analysis tool at that bucket or use another service like EMR or Redshift to do data analysis if you want to create that capability yourself. Passwords. Configuring a strong password policy. It's very simple to do, and it ensures that your users and your data are protected from simple password breaches, password guessing, and other similar approaches. You can configure password expiration, forcing users to change passwords at regular intervals. You can configure password strength, length, and also character mix. And you can also place restrictions on password reuse. And again, an important note is that password policy does not apply to the root user in your AWS account. So once again, a good reason that you should avoid using the root user unless you have special circumstances where you need to do so. Credential rotation or deletion. Obviously, it's normal best practice to delete or rotate credentials, delete those that aren't in use and rotate credentials that are in use. And you can use credential reports within IAM to identify credentials that should be rotated or deleted. For example, identifying credentials that haven't been used for an extended period of time, make them good candidates for deletion. And you can see this information in the IAM console, as I said, and you can grant an IAM user permission to rotate credentials. It's also worth noting that IAM roles for EC2, which we're going to talk about a little bit more extensively later in the session, that performs automatic credential rotation for you. So if you are accessing AWS API endpoints from EC2 instances, we'd strongly recommend that you use IAM roles for a number of reasons, one of those being automated credential rotation. MFA, we've touched upon this already in the context of instance termination, using conditions with an IAM policy to restrict particular actions to MFA authenticated users, but it is just good practice to use MFA for privileged users, and actually I would advocate using it for all users in your organization. It's very simple. You can use a no-cost virtual MFA on most smartphones today, or you can use a hardware MFA, the Gemalto token, for example. And you can use the IAM console to assign that MFA device, and it makes the setup process extremely simple. So this will supplement username and password with a one-time code during authentication at the console, and can optionally be required for API actions, as we showed you earlier. Really would recommend making use of MFA for users on your account. Very simple to set up and very low cost. Credential sharing. There are circumstances where you may want to provide security credentials to third parties, and you can do this using IAM roles. There's some documentation there about the Simple Token service, which is an AWS API endpoint that deals with credential sharing and the provision of temporary security credentials. And this removes the need to share security credentials over the long term or store them. It's very easy to break a sharing relationship, and it has many use cases, things like cross-account access, intra-account delegation or federation. You should never share the static credentials and AWS secret and access key. Always use an assumed role with IAM as a mechanism for granting access to endpoints. So you just create that role, specify who you trust, and describe what the role can do. Then you share the name of that role externally, and there's an API that your federation partners can call in order to gain access to a temporary set of security credentials, which will inherit the permissions with the role that you've shared with them. So it's a very powerful feature and something that it's well worth investigating in more detail. If you check out the URL on the preceding slide, download the materials to access that, you can find out a lot more about how to use that and how to set it up. So I mentioned a second ago, the use of IAM roles with EC2 instances is a very powerful feature. It makes it very simple to manage access keys on EC2 instance, because your keys and secret will also, your access and secret key will automatically be provided to EC2 instances that are assigned a particular role via instance metadata. Supports automated key rotation, enabling you to assign least privilege to the application that is running on an instance. So for example, you may assign an instance the capability simply to write data into a specific Amazon S3 bucket. Use that for a simple backup service of data on that instance. That instance would have no other privileges beyond that. But if you did want to add an additional privilege, for example, maybe you wanted to start making use of Dynamode DB, you can update the policy attached to that instance role, and instances that are already running with that role will gain the capability to write into the Dynamode DB API endpoint, once again with the restrictions that you've specified in the policy attached to that role. So it's a very powerful and flexible way to give AWS SDKs or CLI tools access to AWS API endpoints from EC2 instances. To get started with this, simply create an IAM role in the IAM console, assign a set of permissions to that role, and then launch EC2 instances with that role. And if you're not using SDKs, you can sign requests to AWS services with that role's temporary credentials as well. That's a very, very powerful feature. We'll take a quick look at that later in today's session. And then lastly, for IAM best practices, we've teased this, trailed it quite a few times already when talking about some of these other best practices, but reducing or entirely removing the use of the root account user on your AWS account is a very good idea. It reduces the potential for misuse of credentials. You can do this by entering the security credentials page within IAM, deleting the access keys for this user, and then activating an MFA device for console login for this user, as well as ensuring that you've set a strong password, a lengthy password with a variety of different character types in it, of course, is a good idea. And this will help you secure the root user, the powerful user that can access all AWS resources within your account. If you have a physical location where you can secure the MFA device that you've used, perhaps locking it in a safe, that's also an excellent idea as well. So some best practices for use of IAM. That was something that was requested that we cover following the last session that we did on Journey Through the Cloud Security Best Practices. As usual, there's a lot of depth that we haven't covered there, and if you want to learn more about IAM, awsamazon.com/IAM should be your destination. You'll find many product details there, as well as comprehensive set of documentation and many usage examples showing how you can achieve certain common usage outcomes with the IAM service as well. Okay, we'll move on now from IAM. I'm going to talk about defining virtual networks with Amazon VPC. As you may know, VPC is a virtual network, your own logically isolated area within the AWS cloud that you then populate with infrastructure platform and application services that share common security and interconnection characteristics. You provide layer 2 separation here, so you can lay out your own subnetting topology using your own IP address space, either 1918 address space for non-internet routable networks, or a publicly accessible address space if you're using internet gateways. You can then connect to your VPC via the internet, via IPsec over the internet, via Direct Connect, You can combine those with AWS Direct Connect with IPsec on top of it. And you can combine those to provide multiple connections into one VPC with customized routing, customized subnet topology, as I said a few minutes ago, and also custom service instances such as DNS or time servers that you might place within that VPC. Many sub-features of this service, including things like elastic network interfaces, subnets, network access control lists, which we're going to come to in a few minutes, route tables, internet gateways I mentioned, virtual private gateways, and of course Route 53 private hosted zone for in VPC DNS. VPC topology. A VPC can span multiple AZs, but each subnet must reside entirely within one availability zone. So you want to use two subnets in different AZs for each layer of your network in order to build a good availability strategy or a platform that will support an availability strategy for your particular service or application. And you have control of subnets and of routing tables. And we provide several different template-based layouts that you can use to create VPCs, including a VPC creation wizard. And you can see here an example of running through the VPC creation wizard, creating a VPC with a single public subnet, as this example shows. And then you have options for public and private with hardware VPN, or VPC with private subnet only and hardware VPN. So it's very possible to use VPC to create an area of the AWS cloud that extends your own corporate network but does not have internet access. Probably something that's worth calling out. So it's a commonly used approach for hybrid architectures that customers might adopt. You can use AWS Cloud Formation, which is a templating language for defining and creating collections of related AWS services. You can use AWS Cloud Formation to programmatically define the layout of your VPC, source control that programmatic definition of your VPC layout, and use this as a component of an infrastructure as code strategy where you will version control your infrastructure in the same way that you might version control software. It's an increasingly common trend that we see amongst customers, and it's very common for customers to use AWS Cloud Formation to define and lay out VPCs. And you can also peer VPCs. A VPC peering connection is a one-to-one connection between two VPCs that are capable of exchanging traffic with each other once that VPC connection has been set up, excluding, of course, cases where you might have overlapping address space. It's important to ensure that VPCs that you want to peer with do not have overlapping address space. And this can be used, for example, to create a service VPC that contains shared service components that you may want to share with a number of other VPCs that you might run that might have individual instances of an application. Maybe you're supporting different customers in different VPCs, and to share access to resources. There are also AWS technology partners that provide enhanced networking services for VPC interconnect. Customers and partners like Cohesive Networks, FortiCloud, and others that provide these additional services. So if you do have a particularly complex network topology that you wish to create, you can also look at partner technology to help you achieve that. I want to focus in a little bit during today's session on network ACLs. These are an optional layer of security that acts as a firewall that you can use for controlling traffic in and out of subnets within your VPC. You might set these up with rules similar to your security groups in order to add an additional layer of security to your VPC. You can find more details on VPC ACLs if you follow the URL that you can see at the bottom of this slide. But the basics are that an ACL is a numbered list of rules that we evaluate in order, starting with the lowest numbered, to determine whether or not traffic is allowed in or out of any subnet associated with that particular ACL. You can have up to 32,766 rules. We would suggest that you number rules in multiples of 100 to enable you to insert rules later on if you need to do so. Network ACLs have separate inbound and outbound rules, and each rule can either allow or deny traffic. VPCs come with a modifiable default network ACL, which allows all inbound and outbound traffic, but can obviously be changed to create custom ACLs. And each custom network ACL starts out closed, permitting no traffic until you add a rule. Each subnet has to be associated with an ACL, and ACLs are stateless, so responses to allowed inbound traffic are subject to the rules for outbound traffic and vice versa. This is the default network ACL that will be applied to subnets that you create where you don't specifically associate them with an ACL. You can see there's a default allow here to allow all traffic, followed by a default deny, but the default allow will be matched, and that means that the default is to allow all traffic. There's a couple of different approaches that you can use. The first is whitelisting. So this would be removing the default allow and replacing it with a series of explicit allow statements. Here we are, for example, allowing inbound HTTP and HTTPS. We're whitelisting SSH traffic from a specific network's public IP address range via the Internet Gateway. We're whitelisting RDP traffic, and we're allowing return traffic from the Internet for requests that originate in the subnet by working with that ephemeral port range that you can see in the fifth row of this table, 49.152 through to 65.535. Another alternative approach that you have, of course, is blacklisting. This could be used, for example, for targeted denial of traffic for specific protocols, or targeted denial of traffic originating in specific CIDR ranges. We have a very simple deny here. Maybe there's a scenario where an SSH vulnerability has been notified to us. We want to block SSH on all of our instances in this subnet until we're able to patch the vulnerability. So we're applying a deny rule for all SSH traffic regardless of source. It's the first rule in this NACL, so we're effectively blacklisting all SSH traffic into our subnet and it'll be blocked. We're allowing everything else and then denying everything as the final rule. So that's how you can effect blacklisting with NACLs. Reasonably new feature in the VPC, much requested by customers, is VPC flow logs. And the idea here is to provide better support for a really important aspect of network monitoring, which is customers wanting to debug traffic flows within their VPCs. You can enable this for a particular VPC, subnet, or elastic network interface, ENI. Once you've done so, relevant network traffic will be logged into CloudWatch logs for storage and analysis either by your applications or by third-party tools. You can create alarms which will fire if certain types of traffic are detected. You can also create metrics that might help you identify trends and patterns. And the information captured here includes information about allowed and denied traffic based on security group and network ACL rules. It also includes source and destination IP addresses, ports, the IANA protocol number, packet and byte counts, time during which the flow was observed, and the action, accept or reject, taken by the security group or network ACL rules that apply to this traffic. There's just one illustration there of a partner solution from an AWS management partner, Sumo Logic. They were very quick to provide a beta version of a real-time visualization tool for VPC flow logs just a couple of days after this feature was announced back in June. If you want more on that, check them out at sumologic.com, and you can find Jeff Barr's original blog post about VPC flow logs if you check out the URL at the bottom of this slide. So we've talked a little bit about VPC now. Next thing I'm going to do is show you a demo of VPC creation using the VPC wizard in the AWS console. So here we are in the AWS console. We're operating in the Oregon region here, as you can see in the top right. We're going to be working with VPC here, which is down in the networking section of the console. So we're going to use the VPC subconsole to create our new VPC. And this might be the first step in a workflow if you were going to deploy a new application into AWS that was going to run on a collection of EC2 instances. A logical first step to do that would be to create a new VPC to deploy those instances into. So we're going to start the VPC wizard, and I'm going to create a VPC with public and private subnets. And the wizard is going to create that in a single availability zone for me. So I'm going to show you how to add to it additional subnets that will be in a second AZ for resilience purposes. It's going to name our subnet game front end because this will be consistent with the naming that we're going to use for the rest of the demo. And we're going to drop our two initial subnets into availability zone US West 2A. And you can see that we've got addressing which is populated in for us into the wizard. We can obviously customize this if we want to do that. Has to specify details of a NAT instance that's going to provide NAT connectivity from our private subnet out to the internet. We'll just click create VPC at this point. To change anything else, and you'll see that the resources for the VPC are created for us. Now that our VPC has been created, we can add additional resources to it. I'll just click OK here. You'll be taken to a list of all of the VPCs that are available in our account. You'll see we've now got a VPC called Game Front End. And we can filter here, and that'll restrict all of the resources that are available and visible through the console just to the scope of the VPC that we've selected in filter. And we're going to add an additional subnet here. So we're going to add an additional public subnet to our VPC. We'll call it public subnet 2. We'll put this into a different availability zone, and we'll select a different CIDR block for this subnet, 10.0.3.0/24. We'll create that subnet. And the last thing that we need to do with the subnet that we've just created is to associate it with the routing table, with the same routing table actually as the first public subnet that's being created. And you can see that that is the routing table that ends in 54BD, and it's actually currently associated with the private routing table. So we'll edit that route table, and we're going to change that to the BD route table, and you can see that that'll associate this particular subnet, public subnet, with a routing table that has the default route of the internet gateway for this particular VPC. In other words, we've converted that subnet now into a public subnet with public routing. And you can see now that we've got 3 subnets in our VPC, 2 public and 1 private. And really setting up a VPC via the wizard is that simple. There's not much more to show. Obviously you can go in then and change other settings associated with this newly created VPC, including features like network ACLs. We've got a standard network ACL here, which is the default that you'll recall seeing on that prior slide. That concludes that quick demo. Let's jump back into the slides. Okay, we're going to move on now and take a look at networking and security for Amazon EC2 instances. And as you'll know, EC2 instances are the virtual machines that you can run inside the AWS cloud, install an operating system of your choice on those machines, and obviously run your applications and workloads on there. And the principal control that's available to you to secure EC2 instances is something called Amazon EC2 security groups. And the rules of a security group control the inbound traffic that's allowed to reach the instances that are associated with a security group, and of course the outbound traffic that's allowed to leave them, excluding instances that are running in the EC2 classic network configuration. So VPCs offer inbound and outbound control. By default, though, security groups allow all outbound traffic, so that's something that you need to change consciously if you want to restrict outbound traffic flow. You can add and remove rules at any time, and when you do so, your changes are automatically applied to all the instances associated with that security group after a short period. It doesn't take long for rule updates to be reflected in the control of traffic within your VPC, control traffic to your instances. You can also copy rules from an existing security group to a new security group. And as I said earlier, you can't change outbound rules for EC2 Classic. Okay. Okay, so how do they work? Well, as I said, they control traffic. So here's a hypothetical deployment model. We've got 2 public subnets in our VPC here, and we've got instances in both of them in availability zone 1 and 2. So this could be the VPC that we just created a second ago, actually. And we've got 2 groups of instances here. We've got some game servers that we've put in a security group called game servers, and you can see we're allowing ports on here actually that are associated with running Unreal Engine and with registering those Unreal Engine game servers with Steam Server Browser. And then at the back end, if you like, we've got another security group called API servers, and this is for our web services API that we're going to use for some aspects of maybe state or matchmaking in our game server. So I have a secondary API tier that we're running. And you can see here that we have a reference in that second security group for API servers that allows traffic from EC2 instances in the game server security group, and only that traffic, to access HTTPS on that secondary tier. And this is just to illustrate that security groups are self-referential. You can reference other security groups in them. And this provides a dynamic way to control security policy. So if we add or remove game servers dynamically, we don't have to update the security group on our API server tier. It will automatically provide the policy that allows those game servers to communicate with it, regardless of how many or how few game servers are active at any particular point in time. So it's a dynamic mechanism for controlling traffic. Next thing I want to do is show you a quick demo of creating and working with security groups. So we'll jump back onto the console now and show you that. So back in the AWS console here in the VPC dashboard, looking at the VPC that we created earlier. I'm going to just show you the process for creating security groups here. So I drop into the security groups console, create security group, and I have to name my group. So I'll call this one game servers, as I said a second ago. The description is required. Front end game servers. It's going to be in the VPC we talked about earlier, game front end, and I'll create that. And once I've created it, I'm then asked to add rules. Inbound rules, obviously outbound rules, as we said, the default is allow all. Inbound rules, there are no inbound rules, so it's not permissive at the moment. And we're going to create some rules to allow traffic. Custom UDP rule, UDP 17, 777, then 777, the source is anywhere 0.0.0.0/0. Add another rule, another custom UDP rule. We're going to take traffic on 27.0.15. Again, the source is going to be anywhere for this. That's our first rule. We can save that. And to create our second security group for our API tier, same VPC once again, and here we're going to create a reference to the game servers security group that we already created. Add again an inbound rule. We want to allow HTTPS traffic. The source is our game servers. And it's that simple. We could then launch EC2 instances with these two security groups assigned to them, and that would permit traffic in the way I've described. So I hope you can see how simple that is. The options that I've just showed to you there through the console, of course, are also available via the AWS CLI. And I just want to show you a few examples. So here's a AWS EC2 create security group command. We're adding the group name, the description, and the VPC ID that we want to create the group in. This creates a skeleton group that you can then add rules to. You can find more details on this particular command at the bottom of on the URL at the bottom of the slide. Then you can authorize security group ingress or egress from a pre-created security group. So I'm taking the group ID that was returned to me on the prior slide. I'm using that to authorize the UDP traffic on port 27016 from any source address. And I can then use describe security groups with a filter option to give a name and a value for that key. Name is group-name, and the value in this case would be game servers. Output that in text, and that'll return back to me, and you can see my additional security groups being created there, 27016 UDP. So that just describes how to work with security groups using the CLI. I'm going to move on now quickly and talk about working with container and abstracted services. So these are services like Amazon RDS or Amazon EMR, where we're providing to you managed services essentially that are built using EC2 as a substrate, as a low-level component. And just to give you a flavor of how this works, for example, with RDS, entering into the RDS console, you're asked to create an RDS security group. And this is a reference actually to an EC2 security group, which is assigned to servers, to EC2 instances that you wish to have permission to access your RDS instance. So in this case, I would create an RDS security group for my MySQL master and slave, multi-AZ enabled RDS instances, referencing back to my API service security group, and that would permit traffic from that tier into my MySQL database, routing via the routing table that you can see represented here in the middle of these four subnets. So it's very, very simple to permit access to container services as long as you're familiar with EC2 security groups. Of course, there's another component access to container services, and this is secret. So things like database usernames and passwords. And obviously, this is not managed by security groups. It's something we need an alternative solution for within the operating system environment. It's actually a very good recent blog post on the AWS security blog, which talks about whitelisting for access to sensitive S3 buckets and how you might use this as a mechanism for storing credentials. I'm not going to exhaust this here other than to say that if you check out the AWS security blog that I'll show you a reference for at the end of today's session, there's an excellent new post there that explains how you can use IAM instance roles or STS assumed roles to provide whitelisting capabilities to access credentials that you might store in a bucket. And that's how we'd recommend that you get credentials onto instances where you require them. Because the other type of services is abstracted services like Amazon S3 and Dynamode DB. And in this particular case, it's all about IAM roles. It's about using IAM roles to pass access credentials to an instance, to grant permission for instances to work with the AWS API endpoints that abstract these services like S3, Dynamode DB, and other services of that type. I'm just going to show you a very quick demo now, working with IAM roles via the AWS console. So I'm logged back into the AWS console here, and I'm in another account here which has a very minimal set of resources configured within it to try and show you a nice clean console. Not entirely empty, but almost empty. So jump into the Identity and Access Management subconsole. And creating roles for EC2 instances is very simple. We're going to go into the roles section of the dashboard, and we're going to create a new role here. So we'll call this my game server role. Oop. And we want this to be an Amazon EC2 service role. So it's an EC2 instance role that's going to call AWS services on my behalf. And you can see here there are a number of managed policies that are available for us to attach. We're going to grab an S3 policy here. So say you wanted to have a role here that would have permission, read-only permission, to work with the S3 API and access resources within our account in that API namespace. Well, we can use a managed policy for that. And if I create this role, you'll see that I now have my game server role here with a policy attached to it, which I can show. And I can then start an EC2 instance within this account. So I'll jump over into the EC2 console. And if I was to launch an EC2 instance within this account, you'll see that I have the option when launching an instance to attach an IAM role to it, and my role is available for me here. And that will provide the credentials associated with that role to instances that are assigned to that role via instance metadata, and I'm then able to modify the policy attached to that role, and that will change the permissions associated with that role and modify the permissions associated, or delegated rather, to instances that hold that role. And that's it, really. That's a very, very quick demo showing you how to get started with IAM roles and EC2 instances. Last section of today's session is about encryption and key management in AWS. After we've covered this, we'll talk about some resources that you can use to learn more about security in the AWS cloud. Before we start with some AWS specific topics, I just want to talk briefly about encryption and key management functions. This is how a process like this is typically implemented, generating a symmetric data key, either generated by hardware or by software. And in this use case, symmetric keys are preferable to asymmetric keys because we want encryption of data of an arbitrary size. We also want this to be strong in terms of performance, very fast. So what we do here is use the key along with an encryption algorithm like AES to generate ciphertext, the encrypted data. What about the symmetric key that we've just used there? You can't store that with the encrypted data. That would be a very insecure thing to do. So we need to protect that key somehow. And the best practice here is to encrypt the data key with yet another key called a key encrypting key. This key can be symmetric or asymmetric, but it needs to be derived and stored in a separate system than the one you're processing your data in. After you encrypt the data with this encrypt the data key with this key encrypting key, you can then store the ciphertext, the encrypted key, along with the original ciphertext, the encrypted data. What about protecting that key encrypting key? How do you do that? You can iterate on the process of enveloping that key with as many additional keys as you want, creating a key hierarchy, but at some point you're going to need to be able to access a plaintext key that starts the unwrapping process to derive the final key to decrypt the data, and the location and access controls around that master key should be distinct from the ones used with the original data. Options for implementing this kind of infrastructure within AWS, well, you have a few. The first is DIY key management. This is where you encrypt data client side and send the ciphertext to an AWS storage service, whether that's Amazon Redshift or Dynamode DB or another service. And in this scenario, you need key management infrastructure which provides the keys and manages the keys that are used to encrypt your data. That can run in private infrastructure on your own premises, or of course it can run in private infrastructure inside a VPC on an AWS instance, an EC2 instance. With this implementation, of course, the only place that you can decrypt your data is in your code using the keys under your control. In order to simplify this slightly, we provide a solution for client-side encryption of data bound for S3. It's called the S3 encryption client, and it's integrated into the AWS SDK so that you can minimize the number of calls that you need to make when you're encrypting data before making the put call to put that data into S3. And the encryption client lets you configure whether you want server-side encryption to happen in addition after you put the data using keys that AWS manages, or client-side encryption to happen before you put using keys that you manage. Those are the two options that you have. There's also an option for server-side encryption using customer-provided keys. And in this scenario, you provide a key at the same time as you provide the data that you want to put into S3. In this example, you can see here, the key is then used at the Amazon S3 web server to encrypt the data. It's then deleted, and you must provide the same key when downloading the data in order to allow Amazon S3 to decrypt it. So that's an ephemeral key model where keys are only held temporarily in memory for the purposes of encryption and decryption. Newest service that we launched just last year is a service called the AWS Key Management Service, and this is a managed service intended to make it easier for you to create, control, rotate and use encryption keys. It's integrated with the AWS SDKs and a variety of AWS services that use the Key Management Service to manage keys that are used for encryption of data at rest. It's also integrated with AWS Cloud Trail to provide auditable logs to help with regulatory and compliance activities, for example, recording and auditing each key access event that takes place. It's integrated into the IAM console for key management. You can create and manage keys there, and then it is further integrated with a variety of services, as I mentioned, where KMS managed keys can be used for encryption of data at rest. Here you see an example with EBS, the Elastic Block Store, block volumes that are attached to EC2 instances. Here's another example of integration with Amazon S3, where we're showing use of a key management service master key. And here is an example of integration with Amazon Redshift. We're using it to encrypt a database, again using the KMS service in that use case. Services integrate with the AWS Key Management Service using a two-tiered key hierarchy with envelope encryption. Unique data key is used to encrypt customer data, and the AWS KMS master keys are then used to encrypt those data keys. So it gives the benefits of envelope encryption that you can see there. You've got a small number of master keys to manage rather than potentially millions of data keys that could be in service. So the fundamental characteristics of the key management service are intended to provide security for your keys. So steps like never storing your keys in persistent memory on runtime systems, or automatically rotating keys for you as a system side controls. And then there are process side controls as well, such as separation of duties between systems that use master keys and data keys, or multi-party controls for all maintenance on systems that use your master keys. These controls are documented in public white papers and also in the SOC 1 compliance package, which is available from AWS if you have a non-disclosure agreement with Amazon Web Services that's in force. Okay, so that concludes the technical content for today's session. Some resources that you can use to learn more. Of course, the location for everything security related at AWS, aws.amazon.com/security. It's a great place to go for finding further information about AWS security features, security best practices, and also for finding sessions and other technical content. Might help you understand more about how to secure workloads in the AWS cloud. There's also a great deal of technical documentation. We've referred to quite a lot of it during today's session. Here we're looking at something that compares security groups and network ACLs, a couple of topics that we've covered today. There's a huge amount of technical documentation about VPC, about KMS, about other AWS security features like AWS Config and AWS Cloud Trail. So check out technical documentation for real in-depth content about precisely how to use every feature of every AWS service that we've covered today. You want to check out some blog posts to do with security on AWS. We have a security specialist blog at blogs.aws.amazon.com/security. That's where I found the post about whitelisting access to S3 buckets for credential storage. Also been a lot of other posts on there of note recently. So check out that security blog, put it in your RSS reader and stay up to date with that. I have a collection of security white papers covering security topics in AWS, including the AWS Security White Paper, which is an excellent place to go for security best practice associated with running services on AWS, as well as detailed papers around at-rest encryption, security best practices, logging and governance. Large number of AWS services that we've covered today and several others that we have not covered that are also relevant for secure use cases. Of course, every product and service has its own product detail page where you can find information such as links to technical documentation. So check out the product detail page for each one of these services if you want to learn more about them. For general AWS training and certification information, go to awsamazon.com/training. You find our technical curriculum there with hands-on self-paced labs, certification tracks, and of course classroom-based training delivered around the world. So that concludes today's session. We're not going to have time for questions today. We packed a lot of content in there and we've slightly overrun our time slots. I'd like to apologise for that. My colleague is going to put the webinar into Q&A mode now, though, all the same. And of course, if you do have questions, please continue to submit those using the Q&A panel that you can find in the webinar interface. We'd love to get your questions. We'll get back to you on them in due course if you let us have any questions that might have arisen during today's session. Please do give us a rating from 5 to 1. I'd like to apologise for my voice during today's session. Not feeling too great at the moment. I'm sorry if that was apparent during today's webinar. I'd like to apologise for that. Lastly, please do follow us on social media. You can find me at Ian with 4 M's. You can find us at AWS_UKI for news and information here in the European time zone in the English language. And of course, the UK and Ireland education programme is covered extensively there. Also, the AWS Loft that we currently have open in London. And if you want to stay up to date with AWS service announcements globally, news from AWS reInvent that's coming up 6th to the 9th of October in the very near future, find us at AWS Cloud, also on Twitter. Lastly, I just want to, as always, thank you for giving up a bit of your time to learn a little bit more about AWS today. We do appreciate that. Please do keep submitting your questions and we'll get back to you on them. And please don't forget to rate today's webinar. Thanks again for joining us. Bye-bye.